Mathematics is a great and powerful tool. But like any tool developed by human beings, it has its strengths and its weaknesses. And in some cases, mathematics is not complete. In other cases, there are misconceptions about mathematics. And one of the greatest misconceptions is among physicists, where they tell us that mathematics is the language of the universe. Now, this is where mathematicians should get angry and explain to these physicists that, well, the universe only requires about 11 or 12 dimensions. Mathematicians can go to any number of dimensions, even fractional dimensions. And so therefore, mathematics is a superset of the universe. And this misconception also leads to what I see among students. They throw down equations, they start massaging them and substituting one equation into the next. And they believe as long as they follow the rules of math, anything they derive must be true. That is another major misconception. Now let me put this all into perspective so you understand where I'm coming from. This is an improvement to the diagram I've been showing before. This spiral of numbers, and this is just AI's number gibberish, so don't try to look at the equations, and I didn't do this, I had AI do this, but these represent mathematics. And I call this entire thing the mathiverse. And in the mathiverse, you can have infinite dimensions, even fractional dimensions. So the universe here, which represented by a little galaxy at the center of the mathiverse, this is the footprint of the universe as described by 12 or 11 dimensions of mathematics. It's a small subset of mathematics. And therefore, if you derive something, even though you follow the rules of math, it is possible for you to derive something out here that, although being mathematically correct, does not exist in the universe. And so that is one of the problems of the misconceptions of mathematics, is mathematics is a superset to the universe. And this little thing here represents humans' footprint within the universe, where this actually should be microscopic. And because our footprint is so microscopic, the odds that there could be infinite number of mathematical models that fit our tiny part of the universe should be immense. Another point I want to impart on you is that, we have errors in certain parts of mathematics. Math is by no means complete. There's also parts we don't have definitions for yet, like division by zero. Math is by no means perfect, not yet anyway. And also, like in physics, math can have doppelgangers, and we'll show you all of these things as we go forward. This is the Stinty's Rules of Scientific Acquisition. This is the 7th video, which are the math tells. I have 2 placeholders here, but I think I've resolved one need for one of the placeholders by combining it with the perpetuity perfection tell, the derivation fallacy, the degrees of freedom razor, and the singularity tell. An important point about the singularity tell, because of the high number, this is relatively new. And we've incurred 2 infractions on ethereal mechanics from the singularity tell. This is awesome. This is very important that we find flaws, because flaws are the only way to go forward. And that is one of the problems with STEM training. We're taught from the early ages of class, oh, you got to get the right answers, otherwise it's embarrassing if you make a mistake. You could look like a fool to everybody. And this is the same thing that happens in science. Physicists, when they have an experiment that comes out wrong, they hide it. They downplay it. They say, oh, we might have made a mistake here, instead of data mining it to be able to show that, hey, we found something that doesn't agree with our models. That's great. That is the kind of progress to go forward. You can't fix something if you don't know it's broke, or if you will not admit that it's broke. Okay, so we need to turn this backwards concept that failures are bad. And we even need to get to the people that fund, that give out grants, to show them that if we fail from the grant, that's a better position than if we succeed with the grant. And we need to get people to understand we have it all backwards, that failure is the path forward. When you're a little kid learning to walk, you're not born knowing how to walk. You have to fall on your little butt a couple of times before you figure out the way to sequence your little mud flappers to go from point A to point B. That is the progress forward, is failure. And we need to get people to get backwards, turn everybody around on this, and get this in the proper way it needs to be to make forward progress. There are other tells that are math tells that we introduced in earlier videos. The virtuality tell, the uniqueness fallacy, and the arbitrary tell. We're going to show more ambiguities because math has ambiguities too, and we're going to show more doppelgangers because math has doppelgangers too. So again, one of the misconceptions of students coming out of college is that if they just get the equations right, then nature will do what we tell them. They're in this Harry Potter thing, and mathematics is like this ancient witchcraft language that if they just get the symbols right, nature will do what they want. But again, just because you derive something and you get this thing over here does not mean it exists. Okay, so therefore the 12th rule of acquisition is derivations prove nothing. And when you do have a derivation, you must do experimental corroboration. Now again, just because your theory or your model gets the correct answer does not prove it's true. That's the first rule of acquisition. All you're going to do with this corroboration is to demonstrate that your derivation is useful. That's the best you can hope for. That is in the first couple of videos of the rules of acquisition. And again, just because you derive it does not mean it exists. And let me show you some of the flaws in mathematics. Here, any other number I choose other than 0, I can undo this. In other words, if I say 5 times 0 is 0, but then I take that 0 and divide by 0, I can't get back to 5. But this operation of invertibility, we call that, is good for any other number than 0. Doesn't that just kind of ring a bell? Why is it only 0 we have a problem with? That seems like a big inconsistency in mathematics. I actually have a way to solve this, but I'm going to leave that for another video for another day. Also, if I take the square of minus 2, I get 4. But I've lost all the information of where this came from. So if I try to take the square root of 4, well, what I have to do is, because I may not have knowledge of where this came from, I just have to say it's either 2 or minus 2. Or is it possibly both? No, it can't be both. It's got to be 2 or minus 2. Again, we have loss of information leading to loss of invertibility. Same when we take a derivative of a function. If I take the derivative of this function, we lose the constant, and we end up only with the derivative of this component. Therefore, when we take the inverse process, the integral, we have to make a guess as to what the missing component was. We know there may not even be a missing component here. Okay, so you can see we have lose information when we do a lot of derivations. Okay, so 12.2, derivations lose information leading to ambiguities. And you carry forward on the ambiguity tell from that point there. Now here's an interesting one. I'm going to probably get a lot of really bad hate email and a lot of really bad hate, whatever. This guy, the square root of -1, does not exist anywhere in the mathiverse. No, it does not. But humans have come up with a very interesting way to use it, or at least we think we're using it, called complex numbers, which are wonderful. I use them all the time in engineering. They're gorgeous. They're wonderful. But they're all completely done by fiat, because there is no construct in the mathiverse for imaginary numbers. That's why they're called imaginary, because they don't exist in the mathiverse. They exist in some evil parallel mathiverse, possibly. From complex numbers, somebody said, well, since complex numbers only work for 2 dimensions, let's extend it to 3 or more dimensions. And they did it for 4 dimensions because they found out you can't do a complete multiply in 3 dimensions. That's what I found out when I developed Vortrix algebra. Okay, from there, they've repackaged quaternions into other different packages, all claiming that they're somehow unique or a superior set to quaternions. And I'm going to have a video on geometric algebra showing that their derivation of this is gibberish. And I know that's where the hate mail is going to come from. It doesn't mean your stuff isn't useful. I'm not saying it's not useful. I'm just saying it's basically an evil doppelganger that is blocking and obstructing us from the way forward. And so I'm going to assign all of these the evil Spock parallel universe goatee to mark it that these are not from our universe. These are from an evil parallel universe. And when I did vortex algebra, I wanted to come up with a way so I could do a good divide. So in other words, when I take vector A times B equals C, I want to be able to take C and divide by B to get back to vector A without ambiguity and without all of these weird math rules of complex numbers and this, that. I just want to straight multiply and straight divide. No fancy mathematics tables, none of that stuff. Just a straight logical divide and multiply that if you do it by hand, it's straight and easy. You can do it. It took me a long time to figure out how to do it. Finally did it. And to my surprise, I found out that actually when you take the multiplication of two vectors, it actually creates a matrix. And so we put the brackets around these to denote that these result in matrices. And the important thing that came out of this is that scalars, okay, are actually matrices. So if I want to multiply a vector C times the number 5, the way we do that in the legacy is we use distribution. So we multiply 5 times the x component of the vector, we multiply 5 times the y component of the vector, and we multiply 5 times the z component of the vector. That's called distributive multiplication. But in vortex algebra, well, I could just multiply a diagonal matrix of 5 times C and get the exact same answer. So do we use this distributive or do we do a matrix multiply? Now what's important here is with a matrix, I have more degrees of freedom. Instead of just applying 5 to every single component, I can apply a different value to each component. And because we have more degrees of freedom here, that's where the degrees of freedom razor comes from. Fundamental systems exist toward more degrees of freedom. So we don't need this method anymore. We can shit-can it because we only need one non-ambiguous multiply, which is the matrix multiply. And what we do sometimes in vortex algebra is we represent this like this, but now in vortex algebra, if you're showing 5 times C, you're basically showing this. And sometimes we show it like this to remember that now there are no lone scalars. All scalars exist in the scalar components of the matrices, and they only exist in the scalar components of the matrices. So this solves the problem of complex numbers. Because when we go back to the evil parallel universe square root of -1, which again only exists in the evil parallel universe, well, in vortex algebra, -1 can be written as a diagonal matrix of 1, and then if I take the square root of that, I get real matrix results that fit in our universe. They're no longer part of the evil parallel universe. And more important than that, this new methodology gives us more degrees of freedom. So by getting rid of this, we're opening up for more degrees of freedom, more flexibility, and we're on the path to a theory of everything, which is being blocked by this. Now, this stuff isn't bad. It's still useful, but it can't be part of a theory of everything because it's not even in our mathiverse, because we can't represent real imaginary numbers. We've been doing it by fiat for however long we've been doing it, where this is all represented by real normal numbers in normal matrix structures. Again, we got to get rid of all the doppelgangers, and there's more doppelgangers, but we're not going to cover any more in this video. Vortex algebra, there's an update in the works, a new video to be released before the end of 2025. The new paper with the updates will probably be released to the Patreon members over summer vacation, which is the beginning of July 2025. Let's talk about ambiguity. So when you have mathematical functions, each one of these mathematical functions are unique as long as you can see far enough to where they diverge, where they don't equal. But what if you only had a very small footprint, and for whatever reason you can only see a very tiny swath amongst x equal 1? And that would look like that all of these models give exactly the same answers. Okay, that is due to a constrained footprint where we can't see everything. And this is why I say that because of our constrained footprint, like I showed before, if we have limited information, there's multiple possibilities of what we can fill in on this figure. Could it be a B, an 8, or a 3? And likewise, if we had a limited footprint, there are multiple possible, virtually infinite models that could fit that point I showed here. And this is why I use this picture to represent each of these are mathematical models that can explain everything in the footprint we currently know. And this is where I really get angry with physicists, where they just harping on one old way of doing things. And worse is they teaching that to the younger generations. And they're causing a really bad concept of science. We need to expand out and find as many possible models as possible. Because in this model here, if you had come up with all these different models, well, you would know that if you find a way to get to this part of the universe, you can figure out where they diverge and know which one is the best. The models will tell you where to go look for the best results. That's why polytheism is important. We need to not just have tunnel vision on one set of models. We need to find as many that fit our data as perfectly as possible and then use them to disambiguate. And I've shown an example of this in the earlier videos where I showed that I have 5 different field geometries that fit the same experimental data. Let's talk about singularities. A singularity is a point at which a given mathematical object is not defined, or a point where the mathematical object ceases to be well behaved. Now, physicists have turned this singularity into this black hole thing where there's a pathway to a wormhole to another universe, which is complete bunk and nonsense. A singularity basically means you are not using a model to sufficient. In other words, you don't know what's going on really close. If you have a singularity, that means this is a point where we need to do more work because singularities cannot exist. Singularities do not exist in the rules of acquisition. Singularities indicate that your models are primitive and lacking detail. And all of our models are singularities. So by physicist definition, that means a magnetic field has a black hole, Newton's law of gravity has a black hole, general relativity has black holes, Coulomb's model has black holes. Everything's got black holes if we define singularities as being black holes. Okay, now for the purposes of accounting, I'm only counting all of these as one, because that's only one field we're trying to represent here. So I'm only counting one singularity for this. But now, the strong force, this is from AI. This is an equation AI came up with. But again, we are going to have distance in the denominator. And this is the weak force, blah, blah, blah. Doesn't have a simple universally applicable equation, blah, blah, blah. And then you have to go look for, what is that, the Yukawa potential. So yeah, if we put the Yukawa potential down, it's a singularity too. It's just not an R squared singularity. So in legacy physics, we're claiming 5 fundamental forces that are not unified. Thus, they have to have 5 singularity infractions. Because we don't have any detail, high resolution detail, what happens when particles come within a close distance of each other. In ethereal mechanics, we have this one underlying force model that you can derive everything from. And because we have an R in the denominator, we have an infraction too. That's what I was talking about before. This is the new singularity infraction of, but this is okay. This is at our frontier of ethereal mechanics, which is good. And we know that there has to be detail here because when we derived this in the electrogravity series of paper, it wasn't really an R squared. It was an R squared plus the distance from here to here. And so this is not really singular in the near field. It's singular in the far field because at very far distances from this system, the Coulomb force becomes an R squared effect. And the little extra effect that's in there basically dilutes away to being useless. But in the near field, this is not singular. So already we have one force that even though we use the simplification, which is singular, the actual near field force of this is not singular. In fact, there's 3 or 4 other forces that are in the near field that are based on this. Some are torques that at very far distances become meaningless. So we already have an inroad of how things can look when they're not singular. And I believe ethereal mechanics is the first system in the history of man where we're starting to see the non-singularities. And again, this singularity is at our frontier level. Again, these are little holes of things we don't know. This is ethonics. Pretonics is our abstraction layer, and everything is built upon it right now. And so all of our anomalies and all of our infractions are at the frontier level. And again, though, if we decide that the abstraction layer needs to be corrected, yes, we have to bubble that all the way up through everything on top. So, we're going to do our due diligence on that. And to be fair, the multiple tells of the rules of acquisition suggest that a complete second set of forces exist. Okay, so in fairness, we bump the singularity count of ethereal mechanics to 2. And again, this is going to be at the frontier as well. So the final topic we're going to discuss tonight is perpetuity perfection. And the reason why we have it like this is because these form a sort of duality. And I thought of maybe combining them into perfectuity or perfection. I don't know. I think I'll just leave it like this so I don't confuse the living bejesus out of people. So no exchange of energy is perfect. Therefore, perpetuity is unachievable. Don't worry about reading this right now. We're going to come back to this. So if we take this simulation here, because quantum mechanics says everything is quantized. Even light is quantized. So what I'm going to show you is we got two pulses of light going out. And you see the second one's vanishing. So the first light is if there are no quantized losses in light. And the second one is that would be the light if things were quantized. Quantum mechanics. Now these are both normalized to this guy here. That's why he stays away. Normally he would be dimming out. Just because of our squared losses. But what I wanted to do, I keep him normalized, and then the other guy is referenced to him. So not accounting for our squared losses, this would be just quantization losses. And you can see we lose light much quicker if we decide that light is quantized. Now in ethereal mechanics, light is quantized based on the properties of the medium, but the quantization is so incredibly tiny that we would probably not be able to measure it with any of our instruments. We'd probably have to take observations over very, very long distances. So over very, very long distances, each time the fields of light exchange between the kinetic and the potential energy component, they lose just a little bit of energy. And therefore, over extreme long distances, oops, I'm going to get rid of you. Okay, so over extreme long distances, okay, blue light is going to fade faster than red light. And therefore, over extreme long distances, the universe or the very distant are going to redden, not redshift, redden. Now, physicists are going to say, well, we don't have that problem because we have photons, which just keep traveling in perpetuity forever and ever and ever and ever. Yeah, but eventually they're going to spread out to the point where the telescopes will miss the distant object completely. So it doesn't matter how you quantize it. Light becomes undetectable at some point. And so all this talk of the echo of the Big Bang is complete gibberish. And this is also a solution to Olber's paradox. Quantization is a solution to Olber's paradox. And this is a sneak peek of ethereal mechanics cosmology. This is the typical model everybody shows about how a mass distorts the fabric of space-time. Okay, if you are distorting the fabric of space-time, you are working the fabric of space-time. If you are working the fabric of space-time, you need to expend energy. And somebody will say, well, no, there's no loss here. But no, there cannot be no loss. There has to be loss. No exchange of energy can be perfect. It can be very, 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 very tiny that we may not have noticed it over millions of years, but there can be no perfect exchange of energy. Nothing is perfect. And what this means is that Newton's first law is bunk. And this would be the way the new law would be written. An object's kinetic energy, single body, is alterable by all applied forces, which include the viscous forces from the medium. Unless disturbed, all objects will eventually come to rest with respect to the medium. And that solves a lot of other problems. And we're going to talk about those in the cosmology series, which will be produced right after we're complete with the rules of acquisition series. And the important points here is that energy is alterable by applied forces, is compliant with the vorticality tell, and all objects will eventually come to rest with respect to medium. That satisfies the perpetuity tell. So we put these in here, and you can read the rest of these on your own. Here I talk about the redshift again. So let's look at the punch list for today. Now, I've added Newton's first, second, and third law down here because we're going to have a separate video where we're going to discuss these in complete with all of the rules of acquisition, but I have put in the punch list for violation of the perpetuity tell. The yellows are the new ones for today, and there's a 2 here because Ethonics has 2 infractions. We got 5 here, spread out all over, but there should be 1 for each force reality. Okay, we only have 2 more tells to go, but in total there are 6 rules of acquisition left to go. I don't think we're going to end up with a 39 or 40. I think we're going to be good at 38 rules of acquisition total. But again, we'll find out when the final rule of acquisition video is done. So if you want to support this effort to save humanity from the extinction level event, which is always coming, please become a Patreon member. At $5 a month, you'll see all the technology videos. Maybe not all the administrative videos, because all the administrative videos are for bridge and first officers. This is the repository. When the rules of acquisition video lists are done, they will be posted here in order. So instead of having to find them on the YouTube site, you'll be able to go here and click on them in order at your leisure without all the other YouTube nonsense. If you want to find out how to navigate this, well, the video for that is the intro video to the YouTube site. You can usually get there by etherealmechanics.com, but it gives some silliness about, oh, this may not be but it's going to a YouTube site. If you want to get there by the YouTube, just look up Ethereal Mechanics on YouTube and go for the Ring of Fire with the old effigy of Mother Nature in there. This is the blog site. Great shout out to Sebastian for taking care of this. Again, if I can get enough Patreon members that I could do this full time, I will spend more time here. Right now, I haven't had time to spend any. I spend all my vacation time working ethereal mechanics. Thank you. No more voodoo physics.